In today's lesson, we'll be learning about the cosine law. The cosine law is similar to the sine law in that it is used for acute triangles. In other words, it is not usually used for right angle triangles. If you had a right angle triangle, you would likely use SOHCAHTOA or the Pythagorean theorem. There are three different forms of the cosine law depending on which side length you want to solve for. The cosine law is used to figure out side lengths and not angles. If you wanted to figure out an angle, you would be advised to use the sine law instead. The cosine law is quite intimidating when you first look at it. However, this is how I remember it. If you want to figure out, say, side length A, you would need three things. You would need the angle A, as well as side length C and side length B. As you can see, I've used an arrow to sort of remember what three things I need. As you can see in the equation below, if I'm trying to solve for side length A, I need side length B, side length C, and I also need angle A. You can repeat the exact same process for the other side length. So say, for example, you want to solve for side length B. What you would need is angle B, side length C, and side length A. So just to rephrase, if I'm looking for side length B, I'm going to need side length A, side length C, and the angle B. And last but not least, if I want to figure out side length C, I'm going to need three things. I'm going to need angle C, side length A, and side length B. So if I were to rephrase, take a look at this equation down below. If I'm trying to figure out side length C, I need side length A, side length B, and angle C. You can choose to remember the cosine law using these little arrows that I've used to remember it, or you can straight memorize it. It's up to you. In our first example, we want to find the missing side length in each triangle to the nearest unit. If you take a look at the diagram below, I'm trying to figure out side length B. I need three things. This is how I remember. I need the angle directly across it, and I need the two side lengths which are flanking the angle. So I need side length C and side length A. I'm going to go ahead and label these. The next thing you want to do once you've annotated your diagram is to rewrite the cosine law using the specific side lengths and angles which are given in your question. So I'm looking for side length B, so it'd be B squared equals A squared plus C squared minus 2AC bracket cos of angle B. At this point, we want to substitute in our known values. A is 12, that goes in brackets. C is 10, that goes in brackets. I'm going to put 12 and 10 in brackets over here as well. And I know angle B is 72 degrees. You need to simplify some of these numbers now. 12 squared is 144. 10 squared is 100. Now, this end part is a little bit tricky because you have multiplication as well as cos of 72 degrees. I'm going to do this in two steps. So first, I'm going to multiply 2 by 12 by 10, which is going to give me 240. And I'm going to figure out what the cos of 72 degrees is, and that is approximately 0.31. You can carry more decimal places if you wish. When I'm simplifying this step, you need to follow BEDMAS. So that means I'm going to multiply before I add or subtract. So what I have here is 240 multiplied by 0.31. So you can just throw that into your calculator, and you should get approximately 74.4. So in the next step, all you need to do is add up or subtract these numbers, and what you're going to get is 169.6. If we want to isolate b, we need b all by itself. However, b is stuck with an exponent of 2. So to get rid of the exponent of 2, you need to square root both sides, and that just becomes b. And the square root of 169.6 is approximately 13.0. And since I want to round my answer to the nearest unit, that would just be 13 centimeters. Therefore, we have just used the cosine law to figure out the side length of b to be 13 centimeters. In our second example, we want to solve each triangle. What exactly does it mean to solve a triangle? Well, that means you need to solve for all of the side lengths as well as all of the angles. We want to round our answers to the nearest unit if necessary. So let's begin by annotating our diagram. That is going to be side length r. This is side length q. This is side length p. If we're trying to figure out side length r, we are going to need the angle directly across it, which is angle r, as well as the two side lengths which are flanking that angle. In this case, it would be q and p. You should have noticed that our diagram does not use the letters a, b, or c. However, the cosine law, which I presented to you earlier, does use the variables a, b, and c. That doesn't mean you cannot manipulate the cosine law to use these variables instead. So since I'm looking for r, that would be r squared is equal to q squared plus p squared minus 2qp multiplied by the cos of angle r. So at this point, all you need to do is substitute in your known values. I'm going to put them in brackets. So I have 15 squared plus 13 squared minus 2 multiplied by 15 multiplied by 13 multiplied by the cos of angle 70 degrees. I'm going to simplify this in the next step. So 15 squared is 225. 13 squared is 169. This next little part, I'm going to simplify it in two steps. So I'm going to first simplify 2 times 15 times 13, which is 390. And I'm going to simplify cos of 70 degrees, which is 0.34 approximately. You can always carry additional decimal places if you want your answer to be more accurate. In our next step, you need to remember to use BEDMAS. So you're going to multiply before you add and or subtract. So 390 multiplied by 0.34 is approximately 132.6. So at this point, all you need to do is add and subtract these numbers, and you should get approximately 261.4. Now, if we want to isolate r, we need it all by itself. But right now, it's stuck with a exponent of 2. So I need to square root both sides to get rid of that exponent. And the square root of 261.4 happens to be about 16.17. And if I were to round this to the nearest unit, it would round to 16 centimeters. Therefore, we've just used the cosine law to solve for one of these side lengths. However, in our next step, we need to figure out the angles which haven't been identified. So angle P and angle Q. In the beginning of our lesson, I mentioned that the cosine law is used to find side lengths in acute triangles. If you want to figure out angles, you should be using the sine law instead. So let's again begin by annotating our diagram. we figured out what r was equal to. It was equal to approximately 16 centimeters. 15 centimeters is side length of Q, and 13 centimeters is the side length of P. So right now, we want to try and figure out angle P and angle Q. Let's use our sine law. Again, we're not going to be using the variables A, B, and C. We are going to be using P, Q, and R. So I have side length of R over the sine of angle R, and then I have the side length of P over the sine of angle P, and then I have the side length of Q over the sine of angle Q. What you need to do is just substitute in your known values. For R, I'm going to be using the non-rounded version, so 16.17 over the sine of 70 degrees. I do know the side length of P, which is 13. I want to figure out angle P. And I do know the side length of Q, which is 15. And I also want to figure out angle Q. Let's say I want to solve angle P first. So that means I'm going to be using this fraction. And I need to use another fraction which doesn't have any variables in it. So I'm going to be using that fraction. Let's rewrite these fractions below. 16.17 over the sine of 70 degrees is equal to 13 over the sine of angle P. I need to cross multiply, which is going to give me 16.17 multiplied by the sine of P, which is equal to 13 multiplied by the sine of 70 degrees. Remember, we want to solve for angle P, but it is stuck with a sine and is stuck with multiply by 16.17. I'm going to get rid of the 16.17 by dividing both sides by 16.17. The 16.17 cancels out on the left side, which just leaves you the sine of angle P. Now, you can go ahead and simplify 13 multiplied by sine of 70 degrees divided by 16.17. I've gone ahead and done that already. That is approximately 0.76. So if I want to find angle P, I need to take sine inverse of 0.76. And that is approximately equal to 49.1 degrees. And since our question asks us to round to the nearest unit, that is going to round to 49 degrees. All right, so we just solved for angle P, and angle P turns out to be 49 degrees. Figuring out angle Q should be pretty simple because you know that the interior angles of a triangle adds up to 180 degrees. So let's write that down on the side. So angle Q is equal to 180 degrees, subtract 70 degrees, subtract 49 degrees. So you can throw that into your calculator and you should get a value of 61 degrees. So I'm going to add that also down over here. As you can see, we have solved this triangle. We know all of the side lengths, and we also know all of the angles. And we used a combination of both the cosine law and the sine law. Remember, the cosine law is used to find side lengths, whereas the sine law can be used to find angles and side lengths.